All right. So a student had asked the other day, "Oh, is everything just linear and we can make predictions off of everything?" No. The thing about when we were making predictions off of stuff, we had a pretty limited amount of data that we had used. I mean, this was our one that we had talked about last time. We just haven't cleared it out yet. But we as people, we use observations, and then we make conclusions based on observations. Would you agree with that? So if you go and you watch something happens over and over and over again, or if you walk by the who's that pizza place up there on the corner? Freestyle. So if let's say every day you decide you want Jimmy John's, but every Tuesday you walk by Freestyle Pizza and see that they have a soda and a pizza for $4 or something. And I'm just making hypothetical, but that's every Tuesday, and every Tuesday you do it. Wouldn't you expect that if you were to come back on a Tuesday in a few weeks, it would still be there? The answer would probably be yes, because you've made some observations. Now, is it normal that everything that you notice out there? No. It depends where your priorities are with life. Like my oldest daughter, Leah, who's a freshman, she couldn't find her own way home if I walked her to the end of the driveway and said, turn around and find the house. Okay? But it's not because she's dumb. Every time we drove someplace, she would read. We're going to the grocery store. Oh, I got to go book. It's 3 minutes away. But she honestly didn't know her way in and out of the neighborhood because she was always reading. So she set forth priorities that were important to her and finding her way home. I should find my way home when mom and dad always take me. Or the bus picks me up and drops me off. So it's just kind of funny that way. She's gotten better at it. But on the opposite end of the spectrum, she got, when she was in like 3rd grade, she had high school novels she was reading, and they were just like, we can't test your daughter to tell where she's at because we only go up through 8th grade. So she's pretty well read, it goes along with that. So let's take a look at the other side of this, and it talks about the days since Brexit and the dollar worth of the GRR. So it says, the table below shows the value of the European Tiger Fund stock, the GRR, in the days after Britain decided to leave the European Union. Okay, what'd I do? Oh. All right, so I'm going to walk through the graphing calculator, make sure everything's taken care of. So I need to calibrate my board. I was messing around with the projector. Moved it a little bit. So what was something I told you that your graphing calculator would do, and you put stuff into collect for the data? What do you know about it? If you put something in your calculator into the stat plot, what do you know about it? It's plotted. It's actually going to stay there until you tell it to get out. Okay, so on your calculator, on the calculator, we're going to do this. First thing, go into what?
You have to erase it. Calculator.
You just delete it. Yeah, you click the y equals, then click the little.
All right, there we go. Thank you. You guys are so smart. All right, so under my y equals, I still have my equations that I had created. So I'm going to clear in history. So I'm going to hit clear, and then down arrow and clear. So a few things I want you to note once you've done that. Does your plot 1, is it still on? Is it highlighted like that? It's darkened. If it's darkened, that means that your plot's still on. But your data is still in there from the other day unless you had told it to take a walk. So you're going to hit stat. and then we're going to edit, so that's number 1. And notice, now before you go hit any buttons, so take your arrow, go to the very top of whatever row, and hit the clear button, not the delete button. Clear is this one. And then hit your down arrow, and it'll get rid of that data. Move your arrow over and up to the top, and again hit clear and down arrow. And if any of you have deleted it, well, we got something.
Wait, if it says L1 at 1, is that okay? At the bottom, way at the bottom.
That one like that?
Yeah.
Yeah, you're fine. That's what it should say. So, days since Brexit, so it looks like from 0 to 8 I'm going to put in there. And remember, if you made an error, just use your arrow keys to go back to correct it. And then if you go into number 2, you got 82, 76, 70, 62, 58, 52, 44, 38, and 33. Now just kind of thinking about this, what does it appear that our data is doing? It's decreasing, right? So can we kind of speculate that it might be a negative regression that's taking place?
Yeah.
It might be. And so some things that we might note by looking at this is, just by looking at something, Brexit was kind of a bad thing. Okay, now some people, oh no, it's the best thing in the world. It really didn't hurt our markets too much. We have a pretty strong economy right now, which is great. Okay, it always floors me when we, back in 2008 when we went through this huge recession, and though it seemed pretty bad, where did the money go? It wasn't like, oh, it's all gone now. Somebody had it, so I'm not quite sure what had taken place with that. So we had cleared our information out of our linear equations, the y equals, that's all gone. Now we have our data. Does anyone remember how we can look at our data on our calculator?
Right.
Zoom what? If I hit graph right now, my graph's just set up to what my last Zoom graph was. Zoom 9. So zoom, and we want the stat. Zoom stat, which is number 9. And lo and behold, that appears to be a linear equation. It is decreasing. Okay?
Wouldn't graph do the same thing?
If you would have hit graph, it would have taken you to what your last graph had been. Here, let me show you what it. Don't follow me on this. So if I had done this and if I just hit graph right there, bless you. That's all mine showing because I went back to Zoom of the standard form. So if your window had already been set up, yes. But your window can move anywhere around, which is kind of cool. Okay, so linear regression, correct? So graph calculator, find the equation of best fit. Does anyone remember how to find the equation of best fit?
Isn't it trace?
Not under trace, no. What did we do last time?
Bars.
Vars is where it's stuck at once we get there. Good call. So I'm going to hit stat. Anyone know where I'm going from now?
Calc.
Calc.
And linear regression.
Yeah, and then we're going to go down to the linear regression.
Number 4.
Number 4. And we want list 1, enter, list 2, enter, and then calculate. Boom. That's our linear regression. Yeah.
Mine's not working.
Did you plot the data?
Yeah.
Did you clear out y equals? Is your stat plot on? Here, follow me on this. Ready? Look up.
I got it. I'm good.
It's good? Okay.
Yeah, thank you.
Yep. So the negative 6.2 is our A value. That's our slope. So the slope in the context of this problem is our worth went down $6.2 for each day after Brexit existed. Okay, our y-intercept is our b value, so that would have been what the value of that dollar, or that would have been worth as dollars before the Brexit happened. It was like right the instant. It was at 82.02, and now it's starting to go down. Okay. All right. This linear equation exists on our graph. So I'm going to go y equals, and when I go y equals, we're telling the calculator, hey, I want to put something there, so I can either type it in or I can go find it on my calculator. I'm going to go find it on my calculator because we did our linear regression equation. It's hiding under vars, but now we have to find it. So, linear y equals, we go to vars. Anyone remember where it goes? Statistics. Number 5.
Equation.
Whoops. Vars. Statistics. 5. Over to equation and number 1. So now it's going to plug it in there. And I have to sneeze.
Bless you.
Thank you. Once you put it in there, hit graph. It appears on your graph, which is good. Identify and interpret the correlation coefficient. Again, we're not there yet. I'm not too worried about us doing that at this point. Interpret the slope. We already did. Our slope, yeah. Okay. There you go. Yep. Okay. What's next? Interpret the y-intercept. We talked about that. The y-intercept was at day 0, before the Brexit happened, is what it was worth. So it was worth $82 and whatever cents, whatever a y-intercept was. Solve for the X intercept and its meaning. So the X intercept, 1, with my graph right now, can I see where it's crossing the x-axis?
No.
You see it. So we have to zoom out our calculator. So we're going to go zoom out. It's going to do that. You hit enter once, and now it's going to show it. If you don't do that, your calculator won't calculate it. Your calculator knows how to calculate things on its screen, not off the screen, okay? So we're going to so it appears the x-axis is over here in this region. Okay? So, I want to know what the x-intercept is at this point.
Value.
It is the value. It's going to be 0. So I'm going to go into y equals. I'm going to plot the line y equals 0. And I'm going to graph it. And it's going to give me that red line straight across now. Okay? The calculator is going to allow you to find the intersection pretty easily. So with that, you go to second, calculate. You want to know what the intersection is. First curve is your first equation, so hit enter. Second curve is y equals 0, hit enter. Do we want to guess? No, I don't know why this is ever given to us, but from here. So 13.23 roughly is when we are at 0. So what that means is a little bit over 13 days after this had left Brexit means that that value is down to 0, which sucks. Yeah.
My intersecting isn't working.
Yeah, it's not showing intersect.
Okay, did you zoom out?
Yeah.
Oh, you have to put the other graph in. Put y equals 0 in. Now it'll work. Okay. So did you do linear regression? Stat, calculate linear regression. So there it is. Ready? Y equals vars statistics equation. You know, as soon as that's graphed, zoom out, enter. Plot y equals 0 as your y2. And there we go. Yeah. Okay. Yeah. it's the reason is yours isn't in color. It's right here. It's long here.
How do I get
So second calculate intersect. So some of you have calculators that do it in color, which is awesome. Some of you don't. You didn't put your data in, pal. There, that's what's going on. Step one off. There you go. All right, what else did it say? Anything else? Using your linear regression, approximate the worth of the European Tiger Stock Fund 2 weeks after Brexit. Well, 2 weeks is how much?
14 days.
How much?
14 days.
14 days.
Less
Okay.
than 0.
So, yeah, it's going to be down here. Yeah, oh, shoot. Okay, so that I can calculate now. I don't have to draw a horizontal line. I can calculate an x value. Being that days is our x value, I can do this. Here's my last question. Second, calculate. I want to find a value of 14. So that's 14 days. Once you do that, hit enter.
-4.
Yeah. That means that they got to pay back.
Who do they pay?
Well, it's just some world market that means their buying power is very little. So, and we used to, as the United States, we used to have something called the gold standard. And for all of the currency printed, there was gold backing it. And apparently now we don't have that gold standard. And there's all kinds of rumors. I don't know if
Didn't
this
we
is
have
true.
like $1 million note in the Civil War or something?
Oh, I have no idea. The thing is, during the Civil War, each state was printing up their own currency.
Yeah.
So it might have meant something then, but now it's like, oh, that's pretty cool. Put it in a frame. I have heard rumors that Fort Knox, where our gold bullion was, I have heard rumor, and you know me, I love rumors and I love any type of conspiracy, but I've heard rumor that all of the gold is gone. Where is it at? I don't know. But that's a big old conspiracy thing going on. So, all right. So, let's put those calculators away. If you borrowed one of mine, please go plug it back in. And let's take a look at this sheet that I'm handing out to y'all. One, two, three, four, 6, 2, 3. 1, 2, 3, 4. Ron, was someone sit behind you? Yeah.
Yeah, John.
Johnny. Johnny?
Can you tell me the actually idea of this
Thanks for letting me look off your sheet. All right, this next sheet we're not going to use the graphing calculator on. We're just going to go along with our smartboard. So let's look at the front side, which means the front side is the side that has the holes on the left side of it. That's just kind of your notes. All right, so this is talking about Brittany is trying to improve her time to run a mile. She has started a new training program and is keeping track of her times in seconds, which is Y, based on the number of days into training program X. Her latest results shown in the table. So the first day, time in seconds is 4:45. Third day, 4:40. Fifth day, 4:40. 11th day, 4:32. 15th day, 4:30. And 23rd day, 420. So we're going to use our scatter plot, and we're going to create a line of best fit. We're not going to use the calculator on this one.
Dang it.
Okay? That's all right. The calculator is a valuable tool. But I'm just going to use the first quadrant, and I'm not going to worry about the numeric values. Okay, so what should my label for my x-axis be?
Days.
Days. Thank you. And does it make sense to count by ones in this particular?
No.
No? No, why not?
It won't go to 23.
There you go. Thank you. So days down here, it's going up to 23 days. So, I don't know. Seven's good to only do about there. So let's go by fours. Is that okay? That should encompass it. And then we have time and seconds, so that's going to be time in seconds. And how many seconds do we go up to?
500.
Almost 500? Is that right? 445? Okay, so again, let's not do like science and make the squiggly line. We need to figure out how to count. So we're getting up into the hundreds. So I would say perhaps let's count by 50s. Does that seem okay? 200, 250, 300. Squeeze up to 350, 400, 450, and 500. Is that okay? Does our stuff fit? So we want to make sure that we can fit things onto our data. And let's go ahead and start plotting. So our first day it's at 445. Our first day is like 445, so it's like here. And our third day is at 440. Third day is like at 440. I don't know. Pretty close. And our fifth day is at 440. And our 11th day is like at 432. 15th day, is that what? 4:30? And then 23rd day is at 4:20? Okay, it's kind of hard to look at our data to say, wow, something's really going on. Okay? So let's draw our line of best fit. Something like that. Okay, I did it in yellow so we can still see what our data is. So should I pick two pieces of data right next to each other to start figuring out my linear equation? No. Do I know where it crosses my y-intercept at this point? No. So
The y-intercept.
the y-intercept here.
Oh,
My data doesn't tell me that yet. So I'm going to have to use both of these. And I'm going to have to pick two different points. I'd say that's a pretty good point to pick. And I don't know, that might be a good one. So what is my third value up there? And I'm just picking 2 points
440.
that I think fit my line of best fit. You might have picked one a little bit further out. And then 23, 420. So what should I try and find now? The slope, yeah. So my slope equation's this. So we're going to go 420 minus 440 over 23 minus 5. Which that's going to give me negative 20 over, is that 18? Reduce that, that's negative 10 over 9. Hey, Ram, calculator this for me, 10 over 9, please. Thank you. So right now, this slope in the context of the problem might make it easier for us to establish what the slope means. Because right now, if you look at this negative 10 over 9, this means I drop 10 seconds for every 9 days that I practice. Right? That might make a little bit of sense. Or if I do this, that means that my time drops by 1.11 seconds for every day I run, every day practice. Which way makes more sense with you? I don't know. Okay? So both ways are a legitimate way of looking at it, and sometimes it's hard to fathom in your mind why the fraction's taking place. Okay? Interpret the line, the slope of the linear regression one in the context. Okay? So we have our slope. We will lose 10 seconds of time for every 9 days that we run, or if we convert it to a decimal, we will lose 1.11 seconds of time for each day that we run. Next thing I do is I have to figure out my equation. And I'm eventually going to have to put it into slope-intercept form. So I'm going to use my x1s and y1s that I already labeled. Use this. Is that okay? Let's distribute negative this over the parentheses. Plus, what is that?
5.555.
And then I'm going to add 440 to that. Okay, do I know what my y-intercept is now? Yeah, my y-intercept is taking place at 0, 405.5555. What does that mean in the context of this problem? What does the 405.5555 mean in the context of this problem? Ram?
On her first day of birth, without any practice, she was at 4.5.
Perfect. Before she even started training, her run was going to take 405.555 seconds. And by this person training, she has brought her run time down.
Wait, it's 445.
445?
Yeah, because you added 440.
Oh, it is 440. Thank you. So when she first started, she didn't even start running it. She was like, okay, I probably need to start training. I want to know how fast I can run this in. She goes and runs it. And it says, oh, gosh, 445.55 seconds took you to do this run. And that person said, I need to start training now. And then by training, they were able to shave some times off. Approximate her time 25 days into training. 25 days into training. Is days our x value or our y value? It's our x value. So where should I plug it in, Gentry? Into x. So I'm going to plug 25 in right there. Okay? So I'm going to get y equals negative 1.111 times 25 plus 445.555. And if you have a calculator, that would be awesome. Let's figure out what that comes.
418.
How much?
418.
418 seconds. So by this person training, if this linear model truly did take place, that's what she could tentatively get to. Is there a point that you can't get any faster? Like, will this person ever get to a point where it's like, get it in 10 seconds?
Theoretically, no.
Right, yeah. There's going to be a limit. Now, I still remember in 1978, the 4-minute mile, people were like, no way will anybody run faster than a 4-minute mile. Now we're doing that. But I mean, this was something by the training and the knowledge of the time, they didn't think it was possible. Would we get under a 3-minute mile? I don't know. I guess it could be possible for somebody running. I don't know. That'd be real fast. Holy cow. So that's just a little bit more look into linear regressions. I would like you to try the backside of this sheet for tomorrow. The days on a diet and the time in seconds, that one, it's just trying to sketch it out on your own, and we'll see how we do. I don't plan on having you take any homework home with you over break. I know most of you will be upset by that information, and I apologize if I upset you.
I'm gonna go home.